Hello students, in this session
Let us solve a question on torsion. A cylindrical rod of diameter 10 mm and length 1 meter is fixed at one end. The other end is twisted by an angle of 10 degree by applying a torque. If the maximum shear strain in the rod is P times 10 to the minus 3, then what is the P? So this is the question of torsion, where there is a cylindrical rod. Cylindrical rod is given to us, and diameter of that rod is also given. Length is given to us. The one end is fixed, it is other end is twisted. Torque is applied by twisting, and a 10-degree twist is achieved by applying the torque. If the maximum shear strain in the rod is this much, P into 10 power minus 3, then what is the value of P here? This we have to find out. So let us solve this question.
this question is of torsion in which a torque is applied to a shaft which is fixed at one end, and the length of the shaft is given, diameter is given, and the angle of twist due to this torque, due to applied torque, the angle of twist in degrees is given 10 degrees. Also the maximum shear strain developed in the material is given P, some value, unknown value P multiplied by 10 to the power minus 3. We have to find out this P so that this condition is satisfied, that the angle of twist should be 10 degree, right? So we have to find out basically this value P, this unknown we have to find out, right? How we will use do the question? We know the torsion equation. You have to apply the torsion equation. T by J, tau by R, G theta upon L, right? So torsion equation is, let us solve this question. Torsion equation. What is torsion equation? T by J, tau by R, G theta upon L. Here they are saying that the maximum strain will be obtained when there is maximum shear stress, and maximum shear stress is at the outer periphery, right? Shear stress distribution you will be knowing that the shear stress is maximum at the outer periphery and zero at the neutral axis, right? So this is the maximum shear stress. This is the maximum shear stress, right? At the outer periphery, at both the outer peripheries, we have maximum shear stress. And where there is maximum shear stress, at the same place there will be maximum shear strain also, right? So this is the equation, right? Here tau means tau max because we are taking the outer radius. So tau we mean by tau max because this is outer radius, right? R, right? So from here we can write in this equation, in this part of this equation, we can write tau max upon G modulus of rigidity is equal to R theta upon L. And what is this value? This value, what is this? This stress upon modulus of rigidity, that is the shear strain, right? Shear strain and maximum shear strain because we are talking about maximum shear stress, right? So this is basically maximum shear strain. Strain is stress upon modulus of rigidity, right? That is maximum shear strain, and that is equal to R theta upon L. You have to go to the theory lectures to see that the strain is equal to stress upon modulus of rigidity, shear strain basically, right? So that will be equal to R. R is the half of the diameter. 10 mm is diameter, so half of the diameter is 5 mm, right? So we are taking millimeter, so this is 5 multiplied by angle. Angle is in degrees. You can convert it into radians because SI unit is radian. So you have to multiply with pi by 180 to convert it into radians, right? Divided by length. Length is given to us. How much is length? 1 meter. So 1 meter means 1000 millimeter, right? Converted into millimeter. So answer will come in dimensionless, right? Millimeter, answer will be dimensionless, right? And this value is equal to shear strain, which is given by P into 10 power minus 3. So P into 10 to power minus 3 will be equal to this value, right? 5 into 10 into pi by 180 divided by 1000. So from here there is only one unknown, that is the P. So from here you will get the value of P, that unknown. Solve it using calculator and you will get the value of P 0.88. So answer will come out to be 0.88. So this is the answer of this question.